Okay. The today's lesson we will discuss about diploma first semester subject, that is basic physics. So physics is one of the fundamental subject. So it is common to all branches. It is common to all branches, and the subject code is 103F. So actually 101 for English, 102 for maths, and 103. So 103 for physics. So English, Maths, Physics, Chemistry. So these subjects are common in diploma curriculum uh, in Telangana, SBTET Telangana. So SBTET for State Board of Technical Education and Training Telangana, SBTET Telangana. So in Telangana, in our diploma syllabus, the basic physics is the subject in first semester, and it is common to all branches. And so, my name is L. Shivakrishna, lecturer physics, Gaud Polytechnic, Parakal. Okay. And regarding curriculum, so presently we are dealing with C18 curriculum. So 18 stands for up to in 2008, every 5 years or every certain period, we are revising curriculum. So in 2018, we revised the curriculum, and in revised curriculum, so we have the new pattern. So in the new pattern, we have 6 chapters. So in the next slides, we will discuss about those are the what are the topics covered in C18 curriculum. So basic physics, first semester. One stands for first semester, and three stands for basic physics. So one or three F stands for fundamental. So it is fundamental physics. Basic physics is the fundamental subject, and it is common to all branches: electronics, mechanics, civil engineering, ECE. So all branches, every student should study this basic physics in the first semester. So in C18 curriculum, so we have the so in the teaching scheme, we have internal evaluation as well as external evaluation. So examination scheme. So continuous internal evaluation as well as external evaluation. So in the internal evaluation, we have we have to every student has to attend two mid exams, mid one, mid two, and another one is internal evaluation. There is separate internal evaluation. So this is all for this we have 20 marks, and mid one we have 20 marks, mid two, for mid two the marks is 20, and internal evaluation also 20 marks, 20, 20, 20, 60 marks. So this is about internal evaluation and end examination. So in the end examination, for end examination, the marks is maximum marks is 40, and every student should secure minimum 14 marks. So internal 60 marks, 20, 20 plus 20, and external final exam for 40 marks. So more weightage is given to internal evaluation. So students should regularly complete and regularly read his syllabus, everyday syllabus. Then only he secure more marks, because the more weightage is given to internal evaluation only. And the total periods allotted to this subject is 60, and credits are 3. So this is about the evaluation, the examination scheme of the basic physics. For all subjects, it is common, but I am showing only for physics. Okay. So in the basic physics, we have six chapters: units, dimensions, and friction. First chapter, units, This is very fundamental chapter. So units is a measurement. Unit is a measurement to measure every quantity, every physical quantity. And dimension analysis is also very important. So in the lesson, we will discuss what is the dimension analysis. So units is the measurement, fundamental. So in physics, we have to measure all the physical quantities. We have to convert one physical quantity to another physical quantity. So in every diploma student or engineering student, every student should do some problems and problem. So in order to solve the problems, complex problems, and we need to know the thorough knowledge of the units and dimensions and friction. So friction also you might have some elementary knowledge about the friction. So friction is a resistive force between two surfaces. So what is the friction? What types of friction? What are the advantages? What are the disadvantages of the friction? So we will discuss in the chapter friction. So next topic, elements of vector. So so in school level, we will discuss about we don't have idea about the vectors. So the physical quantities are divided into two types: vectors and scalars. So vector is it is a quantity. It possesses both magnitude and direction. And in mechanics, we will discuss about projections, horizontal projection, oblique projection, and etc. Properties of matter. So in the properties also matter have the important forms of matter is solids, liquids, gases. So in the fourth lesson, properties of matter, we will discuss about properties of solids, properties of liquids and fluids. So properties of three matters: solids, liquids, and fluids. Heat and thermodynamics. So heat is a one form of energy, different forms of energy. So one form of energy. So we are separately studying about heat and thermodynamics. Thermodynamics. So heat related, the mechanics related to heat and con- conservation laws and energy sources. So how to measure how one form of energy is converted into another form of energy, and what are the energy sources presently we are using. So we will discuss about in the last chapter. So these are the six chapters. So after completing first two chapters, units, dimensions, friction, and elements of vector. After completing these two chapters, so student has to write mid one examination. So 20 marks. So mid one examination after completing first two chapters. After completing third chapter and fourth chapter, student has to write mid two examination. And internal evaluation. There is another one, internal evaluation. So internal evaluation, student has to write two slip test 1, slip test 2, that is given by the lecturer. You have to complete assignment and submit within the time. For that you will be given maximum 5 marks, 5 marks, 10 marks. And student has to give one seminar, that is for 5 marks. And finally assignment also. So as for assignment you have 5 marks, total 20 marks. So 20, 20, 20, 60 marks. So this is about the first semester structure of the curriculum, examination structure of the first semester for a given subject. And today we will discuss about first chapter, units, dimensions, and friction. So units, dimensions, and friction. Okay. So unit 1, units, dimensions and friction. So in this lesson, we should study, we should discuss physical quantity, what is physical quantity, and what is fundamental derived physical quantity, what is unit and definitions, SI units, advantages of SI units, so far this is about units, derived quantities, units, definitions. So up to advantages of SI units, we are discussing about units. So next topic, dimension. So in the lesson, dimension. So dimension, second one, dimension. So in the lesson dimensions, we will discuss about what is dimension, what is dimensional formula, definitions, dimension definition, dimensional formula definition, and actually it is repeated. Okay, dimensional formula. Next, principle of homogeneity of dimensions, applications of dimension analysis. So this we will discuss in the lesson dimensions. Next, friction. So units, the three topics: units, dimensions, and friction. This is covered in unit one. So friction. In friction, what is we should know what is friction. What is mean by friction? What are the causes, types of friction, normal reaction, loss of static friction, coefficient of friction, expression for rough horizontal surface, expression for acceleration, displacement, time taken to come to rest, and work done, advantages, disadvantages of friction, methods to reduce the friction. So when your body is moving on a surface, that is, every surface has certain irregularities, that is called rough surface. So no surface is perfectly smooth. Some irregularities are there. So when a body is moving on surface, it is stopped after certain time because of friction between two surfaces. So when before stopping, how much distance moved by the object, that is displacement, how much time taken by the body to come to rest, we have to find out the expression. What is the acceleration of the body? So that we have to calculate the acceleration of the object when it is moving on a rough horizontal surface. And what are the advantages, disadvantages of friction? Finally, methods to reduce the friction. Problems. So after every chapter, we have to solve the problems. So this is about the syllabus of units, dimensions, and friction. So today we will discuss about physical. In the class one, we will discuss about physical quantity and fundamental derived physical quantity, SI units, advantages of SI units. Okay. So physical quantity. So first one, physical quantity. The quantity which can be measurable is called physical quantity. Which can be measurable. So example, mass, length, time. So we can measure mass, we can measure length, we can measure force. So all these are physical quantity. And so, so many physical quantities are available: time, momentum, acceleration, velocity, etc. So many physical quantities are available. So, what is which is considered as physical quantity? Which is measurable. Physical quantities means which is measurable only. It it need not be seen physically. It need not be seen physically. It can be measurable. That is physical quantity. For example, time. Can you know what is can time is a physical quantity or not? Time is a physical quantity. Time. So we can measure time. So time, the units for time is seconds, minutes, hours. So we are measuring time. Can we see time? Are we seeing time? No. So it is not seen. It is not physically seen. Time, we are not seeing time physically, but it is physical quantity because it is measurable. So the physical quantity need not be seen physically. It should be measurable. So measure the quantity, every quantity which can be measurable is called physical quantity. So time is also physical quantity. So the for and the distance between earth and sun. Can we see the distance between earth and sun? It is not. We cannot see. We can see sun, but we cannot see the distance, even though it is a physical quantity. And another example, thought. TOU, thought. Our thoughts, feelings. So thoughts, feelings. Can we measure our thought? Can we measure our feelings? No, they are not physical quantities. They are not physical quantities because we cannot measure. They have also not seen. We cannot see feelings. We cannot see thoughts, thought process. We cannot see time also, but time is a physical quantity because we can measure time. There is a unit for time. So physical quantity means the quantity which can be measurable is called physical quantity. So we here I'm mentioning a few examples: mass, length, time. Okay, this is about physical quantity, and these physical quantities are again divided into two types: fundamental physical quantity and derived physical quantity. Fundamental physical quantity and derived physical quantity. So fundamental physical quantity means the physical quantity which is independent, which is independent. So remember independent, which is independent on other physical quantity is called fundamental physical quantity. So example, mass, length, time. So in the next slide, next PPT, we will understand what is meant by independent. So after discussing derived physical quantity, you are familiar with what is fundamental physical quantity. So it should be independent. So mass is independent, length is independent, time is independent. So there are seven fundamental physical quantities. There are seven fundamental physical quantities: mass, length, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. There are seven fundamental physical quantities. So these are three, and remaining four. These are fundamental. They does not depend on any other physical quantities. So this is about fundamental physical quantity. So in the first topic is physical quantity. It is two types: fundamental and derived. Okay, and derived physical quantity. The physical quantity which is dependent on two or more. The physical quantity which is dependent on two or more physical quantities is called derived physical quantity. So example, velocity, acceleration, force. There are many numerous number of physical quantities. The all other physical quantities except seven fundamental and two supplementary quantities, all other physical quantities are derived physical quantities. The physical quantities which are dependent on two or more other physical quantities is called derived physical quantities. So example for velocity, here one example is velocity. Here one example is velocity. So next slide. Okay, one example is velocity. So velocity equal to distance by time. So velocity equal to distance by time. So distance is a physical quantity and time is also a physical quantity. Distance is a physical quantity and time is also physical quantity. That is mean by the physical quantity velocity depends on two physical quantities, that is distance and time. Since it is the velocity depending on two quantities, it is called derived physical quantity. And force equal to mass into velocity. Force equal to mass into acceleration. Mass into acceleration. So force depends on mass and acceleration. So mass is one physical quantity, acceleration is another physical quantity. So this is also derived physical quantity. Acceleration is also derived physical quantity. It depends on velocity and time. So momentum. So except seven fundamental physical quantities, all are derived physical quantities. And one other way is the quantities which can be written in equation form, which can be written in equation form or derived physical quantities. F equal to ma. So force is written in equation form. Similarly, velocity stands for V stands for velocity. V equal to S by T. So V equal to means equation. So velocity can also be written in the form in equation form. Therefore, velocity is also equation. So the physical quantities which can be written in equation form are also called derived physical quantities. But the definition, basic definition is which is dependent on two or more other physical quantities is called derived physical quantities. So here velocity depends on two physical quantities, that is distance and time. Hence it is derived physical quantities. I think you understood what is the derived physical quantities. So there are derived physical quantities are numerous in number. Next, units. So unit is a internationally accepted reference standard to measure physical quantities. To measure physical quantity. So far we discussed about the physical quantities and example mass, length, time, and etc. We should measure mass, we should measure length, we should measure time. So unit is the internationally accepted reference standard, and presently we are using SI units. So there are different types of units are available, but we are using SI unit. It is a internationally accepted reference standard to measure physical quantities. We should know the meaning of this sentence. For example, mass. Okay, okay, mass. So I can measure mass in different quantities. I can measure mass in different quantities. For example, in India, we are measuring mass. So, um, so earlier we are using different measurement systems. So CGS system, MKS system, FPS system, pounds. So in FPS system, mass is measured in pounds. So this is not equal to, okay. So in FPS system, mass is measured in pounds. In MKS system, mass is measured in kilograms. So different units are there for the same quantity. So we are replacing all the units with one unit, that is SI unit. It should be internationally accepted reference standard. So according to SI system, the mass is measured in kilograms. Okay, mass is measured in kilograms. Okay, in India, we are measuring mass in kilograms. In US, in UK, in different countries, we are measuring mass in kilograms. In everywhere, the kilogram should be equal. That is important. That is important. Then only it is internationally accepted. If I am giving 1 kg of fruits to my friend who is living in US, if he measure that fruits, it should be 1 kilogram only. There also in US also it should be 1 kilogram only. How it is possible? When it is possible? It is possible only when this unit should be well defined. It should This unit should be well defined, and there should be a reference for this kilogram. There should be a reference for this kilogram. How much weight should be considered as kilogram, and what is the reference? That should be well defined. Then only it is equal. Then only it is internationally accepted reference standard. So presently the uh, kilogram. The reference for kilogram is a platinum iridium cylinder which is kept in, so international, which is kept in Paris. So International Bureau of Standards in Paris. So in Paris, one museum is there. There one cylinder is there, a platinum iridium cylinder. The mass of that platinum iridium cylinder is taken as 1 kilogram. So every country should follow that. Then only that is considered as unit for mass. So for seven fundamental physical quantities, there are well-defined units are available. Then only it is valid internationally. So the characteristics of unit, it should be easily understandable. Everyone should understand what is kilogram, and it should not change with physical factors. It should not change with the place and time. Every place, every time, a kilogram should be equal. I'm telling about one example. It should be easily duplicated. Whenever you go, you can reproduce kilogram. It is properly defined, well defined. So this is about the unit, internationally accepted reference standard. So SI units, international system of measurement used universally. So in SI units, it consists seven fundamental units and two supplementary units. Remaining are derived units. Fundamental units. Okay. Remember this table very carefully. So here we are. I'm giving examples for. I'm giving seven fundamental units that are length, mass, time, electric current, temperature, luminous intensity, amount of substance. Amount of substance. So length is measured in meter. Meter is well defined. There is a definition for meter. How much length can be considered as meter? So meter is well defined. Every unit, fundamental unit. So every fundamental unit is well defined. The unit which is used to fundamental quantities are called fundamental unit. So these are seven fundamental quantities: length, mass, time, electric current, temperature, luminous intensity, amount of substance. These are seven fundamental physical quantities. The units to measure these seven fundamental physical quantities are called fundamental units. These are fundamental units: meter, length, second. So second is the fundamental unit to measure time, and electric current. Ampere is the fundamental unit to measure current. Temperature, and Kelvin is the fundamental unit to measure temperature. So temperature also measured in Celsius, Fahrenheit, but Kelvin is the fundamental unit, SI unit, internationally accepted unit. It is well defined. All these units are well defined: meter, kilogram, second, ampere. What is ampere? What is Kelvin? What is candela? What is mole? All are well defined. You can search in internet. What is that? What are the definitions? They are very some complex. We may not understand, but they are well defined. And there are symbols for units also. The symbol for meter is small m. The symbol for kilogram is kg. Second, for the symbol for ampere is capital A. The symbol for Kelvin is capital K, and symbol for candela is CD. The symbol for mole is mol, MOL. And there are certain rules. There are certain rules while writing the symbols of units. While writing SI units, these are SI units. This box indicates SI system of units: fundamental units and supplementary units. Some rules. I'm explaining some rules. See, units. When we write the symbols, when we write the symbols of a unit, it should be written in small letters. Rules. Here only I'm explaining what are the rules. Okay. So number one, that is small letters. They are written in small letters. Symbols of units are written in small letters. So the symbol for meter is small m. The symbol for kilogram is small kg. The symbol for second is small s. But here see that the symbol for ampere is capital A. The symbol for Kelvin is capital K. The symbols of units named after scientists should be written in capital letters. That is capital A, capital K. So in the seven units, ampere and Kelvin are scientist names. Scientist names. The symbols of units named after scientists. That is, ampere is a scientist. Ampere is the scientist name. Kelvin is the scientist name. They should be written in capital letters, and remaining units should be written in small letters: candela, mole, kilogram, mass, meter, kg, and second are written in small letters. The symbols of names named after scientists should be written in capital letters. These are the rules. And another rule is there: when we written in when we written the full name of the unit, that is meter, metre, meter, second, second. When we written the full names of the units, They should be written in small letters. Meter, all small letters. So even first letter also small letter. M, K, S, A, K, C, M. All should be written in small letters only. And the units should the units always in singular form only. Meter, kilogram. No kilograms, no meters, seconds. So yes, 10 meters. Should not write yes, 10 meter only. It should be in singular form only. So these are certain rules of writing SI units. And next one, derived physical quantities. The units which are derived from fundamental units are called derived units. Okay. So these are some derived units. These are some derived units. They are so area. So area. Why it is derived units means area depends on two quantities, length into length. Even though same quantities, it depends on length into actually length into breadth. So it depends two quantities, length into breadth. So length is measured in meter, breadth is measured in meter, meter into meter, meter square. So in this way we have to derive the units for derived physical quantities. Units for derived physical quantities. And volume. So length into breadth into height. So meter into meter into meter, meter cube. Next density, mass by volume. So volume unit for volume is meter cube. So mass unit for mass is kilogram. So kilogram by meter cube. So kg per meter cube. Kg per meter cube is a unit for density. Velocity, length by time. So velocity depends on length and time, and acceleration depends on velocity and time. So every derived physical quantity is depending on other physical quantities. Acceleration, velocity by time, momentum, mass into velocity, force, momentum by time or mass into acceleration also. Pressure, force into area, work, force into distance, power, work by time. There are some alternative units which are accepted in SI unit, that is Newton. Actually, in SI system, the units for all the derived units, all the derived quantities should be expressed in fundamental quantities in terms of fundamental units. kg is fundamental unit, meter is fundamental unit, second is fundamental unit. kg meter per second square is the unit for force. It is also called Newton. So Newton is nothing but kg meter per second square. So F equal to force F equal to ma. So m is the mass. The unit for mass is kg, and a is the acceleration. The unit for acceleration is meter second square. Meter per second square. Meter per second square. So meter per second square. Okay, meter per second square. So kg meter per second square. So unit for force is kg meter per second square. It is equal to Newton. So Newton is because Newton is the familiar unit. Newton is the familiar unit. So instead of Newton, we can write kg meter per second square. Similarly, pressure, the unit for pressure is Pascal, familiar name Pascal. But in terms of fundamental units, kg per meter per second square. So pressure is force by area. Force by area. The unit for force in terms of fundamental units, kilogram meter per second square. So pressure equal to force by area. We can derive easily by using these equations. So kg meter per second square. Kg meter per second square. So if the unit for force is kg meter per second square, it is called Newton. It is called Newton. The unit for area. The unit for area is meter square. Meter square. So by using simple mathematical, we can solve this equation. Kg meter per second square, and m by m square. So m by m square, we can get m power minus 1. So kg remains same, but m by m square means m power minus 1, and s power minus 2 remains same. Kg per meter minus 1 means per meter. Kg per meter per second square. See, the unit for pressure is kg per meter per second square. It is called Pascal. So well known unit, Pascal. So these well known units also acceptable in SI system. So Newton means kg meter per second square. Pascals mean kg per meter per second square. So this is about derived units. There are numerous number of derived physical quantities and derived units. We have to derive the units by using these equations. By using these equations, if we know power equal to work by time, get the we can derive the unit for power like this. And SI system provides SI system provides other advantages of SI system is it is providing multiples and submultiples. So multiples are used to measure multiples are used to measure larger quantities, whereas submultiples are used to measure smaller quantities. So these are multiples. Okay. So 10 to the power of positive numbers. These are multiples. 10 to the power of 1, deca. It is called deca. The symbol is DA. 10 to the power of 2, hecta. 10 to the power of 3, kilo. Symbol small k. 10 to the power of 6, mega. Symbol capital M. 10 to the power of 9, giga. Symbol capital G. So we see here 1 kilogram. So kilo means 10 to the power of 3. Here small k indicates kilo. So kilo means 10 to the power of 3. So G for grams. And megameter. Here capital M stands for mega. Mega means 10 to the power of 6. So in capital M, in the place of capital M, we can write 10 to the power of 6. So small m is the unit, 10 to the power of 6 meter. 10 to the power of 6 meter. So instead of writing 6 zeros, 1 meter, we can simply write megameter, 1 megameter, 1 mm. We can easily write 1 mm. Instead of writing 1 000 000, we can easily write 1 megameter. So the multiples are used to measure larger quantities. They are provided. So what is 10 to the power of 1? What is 10 to the power of 2? That is hecta. 10 to the power of 3 means kilo. 10 to the power of 6 means mega. 10 to the power of 9 means giga. So this is about multiples of SI units and submultiples of SI system. SI system also provides submultiples to measure smaller quantities. So deci means 10 to the power of minus 1, 0.1 deci means. Minus 1 means, so after point, after decimal point we have 1. So zero point 0.1 deci, 0.01 centi, 0.003, 0.001, that is milli. So milli means 10 to the power of minus 3, micro means 10 to the power of minus 6. Symbol mu. Centi, the symbol for centi, 10 to the power of minus 2 is C. And nano means 10 to the power of minus 9. The symbol is capital N, so small n. Pico, 10 to the power of minus 12. Femto, 10 to the power of minus 15. Atto, 10 to the power of minus 18. Jepto, ecto. So these are submultiples, smaller quantities, very, very smaller quantities. To measure smaller quantities, we are using submultiples. Okay, see this, 10 to the power of minus 1 gram. 10 to the power of minus 1 means deci. The symbol is D. In the place of 10 to the power of minus 1, we can write D. Dg means decigram. Next, in the place of 10 to the power of minus 2 grams, minus 2 grams, 10 to the power of minus 2 can be replaced by centi, symbol C. So Cg, C stands for centi, centigram, centigram. Centi means 10 to the power of minus 2. Similarly, milligram, 10 to the power of minus 3 milligram. So symbol small m. In the place of 10 to the power of minus 3, we can write small m. Here small m stands for milligrams. Remember, small m stands for milligrams. So small m, here small m is the submultiple and small g is the unit. We are prefix. We are writing submultiples or multiples in the prefix before unit, before unit. So before gram, we are writing submultiples, that is milli, so mg. Instead of writing 0.001 gram, we can simply write mg, that is milligram. So these are the uses of submultiples. To measure smaller quantities, we are using submultiples. So femto, 10 to the power of minus 15. So to measure the radius of nucleus, we are using this unit, femtometers. And pico means 10 to the power of minus 2. The capacitance, you might have heard about capacitance. Capacitance, so the unit for capacitor is in the order of pico or microfarads. So pico means femto, F pico Faraday. So PF, F means Faraday. So picofarad, simply writing picofarad means 10 to the power of minus 12, 0.10 zeros, 11 zeros after 1. That is a very small quantity. We cannot write, it is very difficult, 0.0000 up to 10, 11 zeros after 1 and picofarad. Simply writing PF, picofarad. So these are the advantages of submultiples to measure smaller quantities. Okay. So this is about SI system. So in the next class, we will discuss about advantages of SI system and dimensions. So far we discussed about physical quantity. It is two types: fundamental and fundamental and derived quantities. So fundamental, how many fundamental quantities are there? There are seven fundamental quantities. All are derived quantities. Fundamental and derived quantities. And SI units. SI units also same. SI units again divided into two: fundamental units and derived units. Fundamental units seven, again seven, and remaining all are derived units. Derived units. So fundamental units, the units which are independent, they are independent, and derived units, they are dependent, dependent on fundamental or derived, both. They are dependent, simply they are dependent. So SI units two types: fundamental units, derived units. There are seven fundamental units: mass, kilogram, second, mass, kilogram, second, Kelvin, ampere, candela, mole. There are seven fundamental units. So remember, you should not confuse about physical quantity and units. Fundamental units, there are seven fundamental units: mass, kilogram. So mass is a physical quantity, kilogram is a unit. Both are interrelated. Physical quantities, units are measurement of these quantities. Units are measurement of physical quantities. Okay. We discussed fundamental derived quantities and the rules of writing some SI units, multiples and submultiples of SI units. So up to this we discussed in today's class. And tomorrow class we will discuss about advantages of SI units along with next topics that are dimensions of units.